Hello, everybody. Thank you for coming to today's In Italian Informational. Today, we are joined by Babita, who's going to tell us a bit about the importance of testing and how it's helped her. So here's just a brief description or introduction for Babita. She is a director of quality for the software and informatics division at Agilent Technologies. She has over 25 years of experience in quality organization with a reputation for designing, executing, and re-engineering testing processes to produce significant cost savings while driving successful development and launch of high-quality revenue generating products. She leads a global quality organization in the US, Germany, France, Australia, and some other countries. She has her bachelor's in engineering from India, and she believes in lifelong and continuous learning through books, online, and in class and on-the-job learning. She has played a pivotal role in Agilent's agile transformation, leading to predictable, higher quality releases. She's customer focused and always looking for innovative ways to incorporate quality early in the release. She's developed various processes being used by other teams in Agilent and helps other teams to incorporate FDA's data integrity and regulatory requirements into the product lifecycle. Prior to Agilent, she managed teams in HP Software, where she was responsible for the quality of enterprise software products used by Fortune 1000 companies. So that's just a bit about her, and now I'll hand it off to her.
Hello, everyone. I am passionate about testing and quality, and that just defines who I am. So I will ask all of you to stop me, ask me questions. So testing is a process by which you measure a product's features, performance, safety, quality, and compliance meets with some established standards. And you can see it's not just software, it is for automobiles, it's for medicines, toys, medical equipment, software, construction, anywhere you go, you need it tested. And so there's one thing, people use the word quality assurance and they use the word testing, and they think it's all the same thing. But what quality assurance means is you develop a set of processes and procedures and you monitor things, and that is like a systematic, being very planned and systematic. That entire set of activities that you do to make sure that the final product is of good quality is called quality assurance. So from the beginning, from the moment that you buy the machine or you buy the computer that is going to develop the software, right from that point, the person you hire, did that person get trained, all that comes under quality assurance. So they are not, so testing is a part of quality assurance. Quality assurance is the big umbrella that it falls under. So I've mentioned like some examples, quality of raw materials. So if you're doing manufacturing, it's raw materials. If you're doing software, sometimes you buy a component, something like, an Adobe, or you would want to link to Google or something to do one particular action that you want. So you want to make sure that that component that you buy you have made sure that that's also of good quality, or at least that company is going to be around. So imagine if you depend on something and tomorrow that company is gone, you didn't do your due diligence to make sure everything. So that's why there's a difference. And you can see the testing is just one tiny bit of this entire quality assurance. So I'm giving an example which all of, everybody is going to think. It's a baking company, right? They had a problem. So they had some loaves of bread that were contaminated with wood. And why would you think, so what happened? So they used to send the loaves on wooden trays to a retail store, but they never bothered looking at the tray itself because they thought the tray is not of any concern to them. They were making the bread right. So that's where it shows that you have to look at all, even the peripherals of everything that you produce. The second thing that happened was medicines was shipped to South Africa. And this was something like a fever medicine. And this batch of medicines was missing the active ingredient. So there were children who were continued to die, even though they were taking medications and doctors did not know what happened. And so what had happened was they decided they could not make the active ingredient. Active ingredient is that small bit that actually cures you, not the sugar around it. So that bit, they forgot to put that in. And they had bought it from another vendor, and that vendor also had forgotten to put it in. So they missed it twice. They did not check the vendor. And second, they didn't test it to see whether the medicine actually had everything that they had. So there were two problems that were encountered as a part of that. So this is the reason why, and I've given examples non-software related because I think these are more easy for everyone to understand, and also to realize that you don't need to only go into software to do testing. You could be in anywhere in any industry and you would still need to do testing. So now we come to software. So software quality and testing. Again, quality is a degree of excellence. And so you always say you want high quality software. And that means it meets user requirements. But not only what the user said they wanted, but also where the user did not know that they wanted it. So nobody wants their program to crash ever, right? So they will not say, we do not want the program to crash. The program, so those are the things, or they want it to work under all kinds of circumstances. Nowadays, your website, you go to Amazon.com, you want it to work on your little small smartphone, you want it to work on your laptop, you want it to work on your iPad, you want it to work on a Kindle. So everywhere it needs to work. So those are what we call even not specified, because no one tells you what, those are the things you just think about. And software testing is the process by which you identify the correctness and quality of that software program. And the purpose is to check whether the software satisfies the requirements, needs, and again, the expectations of the customer. So very important is not just the requirements, but also the needs and the expectations of the customers. So why test? Developers developers will tell you we produce really good code. It's absolutely a thing, but everyone's a human. We all make mistakes, and some mistakes may be unimportant. The button instead of green became blue. Yeah, that's okay. But some are expensive and they're also dangerous. So we test to prevent defects, to find defects, and to make sure that the product meets the business requirements, and to gain confidence of customers by providing them a really good product, right? So why does everybody buy a Mac or an iPhone or something? It's because everybody says, oh, the quality of a Mac is much better than something else. So I think that is what you want. You want that trust that the customer has in you. And this thing that I have here, functionality, usability, reliability. So it's not just the requirements, but also, is it easy to use? Is it, does it function? Is it reliable? That means it never crashes. You can turn it on in an instant. Is it slow or is it fast? Can you figure out if something went wrong, do you know how to solve it by yourself, or do you need to call tech support, right? So that is what it is. And I thought I'll find some significant software defects recently. So in March 2017, Amazon Web Services went down for 24 hours. So an employee thought they could just put in a quick fix without testing because it was so minor. But what happened is it took them 24 hours to bring it back up. And that fix they were doing was not even that important, right? That issue that they were planning to fix was not a deal breaker. So, things like that happened. In February 2020, Heathrow Airport came to a standstill when a defect was found in the check-in and departure boards. In 2019, Facebook and Instagram could not upload photographs after a routine update. And then the last one is very significant. Like you can see here, it's about spacecraft, where a software bug which prevented it from slowing down to its final descent on the moon surface. So really, these are very significant defects, which just to show you that sometimes you hear testing. This is what happens if you don't test enough, or you undermine the importance of testing. Now, these are words you will hear, and I just wanted to cover what it is. So manual test is when you manually go through, you click on each thing and you say, okay, does this work? Does this not work? Then sometimes you want to automate these tests. And automation means you write code to test something. And the level of coding that you do depends on, you know, how good you are. So some people will write like really complicated code. And then you have these tools called Selenium and Robo Framework, which you guys can try. They're all free. They both are open sourced thing, and you can use JavaScript to do it. You can also do some playing with record and playback. Very easy tools. You'll find plenty of things online to help you guys if you all want to try it out. They're really fun. Just I would tell everyone to please try it out. And what you can do is, like, suppose you have, I'm going to give an example, a calculation. And, you know, the person said it's 1 and 2, 1 plus 2 is 3. You know that works, and you can try 6 plus 7. But then you want to make sure it works for all kinds of numbers, because maybe you've put some logic, like if it is beyond 1000, please add 20 or something. And you want to make sure it works with all kinds of combinations. So you can take like a comma delimited file and put a whole bunch of numbers and a whole bunch of results. And then every day you can run this programs to make sure that that is indeed happening. So you can do that. You could also do it just by entering a whole bunch of values in a string and say, okay, test with 1, 10, 100, 200, 500, whatever, and do it. So you can have fun writing your own code, and that's what's called automation, is so that you can do continuously and you can do it by automation. So black box testing means you do not know how it is coded, what it is coded. You were given a box and you are going to make sure that that box works. So you don't care about if they use Java or they use C# or C++ or JavaScript or Node.js, who cares? Python, you don't worry about it. You just know you have to test it as a black box. And then white box is the opposite. White box means you know, and you can actually write code, and you can actually dig deep into the code and find problems for them. And for that, again, so the difference between a black box tester and a white box tester is usually a white box tester is as good as the developer, because they have to go in and look at it from that way. And then regression testing is a word that is used to make sure that any new code that you have introduced has not created any new problems, because every time you introduce new code, there is always a chance that you could introduce some problems. So the impact, you didn't realize that if you added this, then that other function will stop working. And so that's why you do regression testing. And then there's another thing called gray box, which is between black box and white box. And that's why they call it gray. And that means you kind of know something, but you're not totally sure. But in that case, you can write some intelligent test, because you saw that the developer is not very good with something, and you can actually write a test to break them. And so how do you test? So the biggest thing I always tell people is be curious and explore. And this is a very nice example that I have. Become Christopher Columbus. And he actually was on his way to India, but discovered America instead. But he discovered something. So this is, you might not find what you expected. So when you're testing, you're looking, you may not find what you tested, but you will find something that nobody knew about or never have seen before. And an example I'll give you is I used to test a banking software, and everybody knows divide by 0, right? What happens if you divide a number by 0?
You get an undefined error.
Yeah, so there was this one company, they had a banking software, so very important. So they had a divide by 0, the error happened, nobody noticed it, but what would happen is all the fields in a calculation form which were disabled would get enabled. And these bright brokers, mortgage brokers, decided to type values inside there because they used it as a feature. And they started cheating people in their loans. And so I joined this company. This was one of my first defects that I found, and we fixed it. The next day, we got so many calls about, hey, we used to make loans for this stuff. And we said, but that's not legal. Yeah, why do you care was the answer. You just make the software. So it's kind of like that. So I was exploring, I found something, but another person explored it, found this problem, and actually ended up using it to actually do something bad. So this is what I say. And I didn't know, I had no idea. It was my third day in that company. I didn't know how banks worked. I didn't know how calculations worked. So I was actually exploring. I was going through each screen, trying to figure out if I typed in 0, what would happen, kind of being inquisitive. And curious George is what I would say. You have to have that mindset. And so again, I say, have a mindset to find faults. You want to break it. How do I break it? You have to have that mindset. You need that, that naughty boy mindset that you have as a teeny kid. You wanted to break your toy car and take out the wheels and all that stuff. You want that in your head. And always do not assume that the person who's using the application is computer literate. You need to, I always tell people, you put like a stupid or idiot hat on your own head when you're testing. Don't, just because you're computer literate, the other person may not be. And an example of this is actually only Rocky will understand this. When first computer DVDs came out, you pressed it, the DVD player came out and it had a small circle in it. I was on a support call and somebody asked, okay, we got this thing from you guys, what do we do? So I said, put it in your DVD drive. And he said, where's the DVD drive? And I said, there's this button, can you see it? He opened, he said, oh, the coffee, my coffee mug holder. So that was his, level. So for me, stupid, that my instructions to him were put the DVD, install from DVD, and the guy had no idea that he had to even open this thing, and there was a circle there. He kept saying, what do I do with this disc? What is it that you guys sent us? So that is my stupidity, to think that everybody else knew that there was something called a DVD player. And so another word you'll hear a lot when you hear about testing is test cases. So what are test cases? They are instructions and variables and a scenario that you will run to make sure that the software satisfies the requirements. And why, again, it's the same thing. I'm just repeating again and again, is finding the defects before we release, is help decide whether the product is ready to ship. Is it working as designed? Will people have to call tech support? You do not ever want anybody to call tech support. Are there any regulations? So as you know, I work in pharmaceutical things. So I have to make sure that I also meet FDA regulations. So I have to see not only software, but I also have to see, are there any FDA regulations? I used to work with banks. I have to make sure that there are financial regulations that I meet. So that's very important. And, representative of what a customer will do. Again, that idiot hat thing. If you develop for a nursery kid or a kindergarten kid, it is going to work. If you develop, say, for somebody who's in school for computer science, it will always work for sure, because the developer is going to be a computer science student. And so now this is the fun part. I want everybody inside this, right? I want everybody thinking about this. So very simple. There's a login screen. All of y'all have gone to your Googles and all the various other pages. Simple. It's a login screen. Now I want everybody to think, if you were asked to test this login screen, what are all the tests you would do? Come on, let's get started.
I would try to put various values, try to put like an email address that isn't actually an email address. Maybe like not put the domain name or something.
Okay.
And then see if I could break it by going to inspect element and disconnecting the JavaScript.
Cool.
I would try maybe like inputting the same email 2 times to see if it'll like allow you to sign up again with the same email even though you've already signed up with it. Oh, I'd also test all like the components of it, including like maybe like the domain sign in or like the forgot password or something like that.
Mm-hmm. Okay.
Basically, just like test every possible feature there is. I think most things are covered, but like log in with Google, try to do that. Log in through social media. Just try different aspects. I think That's what I would do.
How about using special control characters?
Cool. Yeah.
I think one thing too, if there's like a remember me, like checkbox, maybe testing that out.
So I'll show you what I came up with, okay? And I want you all to look at that. So this is the first page of my test. There's a second page to follow up. This is what I ask every time I interview people. This is my interview question. I'm giving it to you guys. And if people can't give me at least 10 test cases, they don't pass the interview.
So I just had a quick question, if that's okay, in the previous slide. So I think one of the test cases was verify the messages for invalid logic. Can you just talk a bit about that and like what exactly that means?
So you want to make sure that that message is correct, right? So suppose you had invalid password and the message does not actually tell you that. It says error happened, which happens a lot. But then I don't know what error happened, right? Was it an invalid password? So if you are doing something wrong, like even if you said forgot password, and usually at forgot password, they usually ask you for your email. But then I got this recently, the thing said invalid and it stopped. And I have no idea what was invalid. Was it thing? So make those, what I tell, and I call that supportability, is make sure that the message that comes out is something that can help the customer solve the problem on their own rather than scratch their hair to figure out what happened here, right? So that's what that is. And there's a bunch more, I mean, from security point of view that you would do it. These are only like, I've captured a few over here because, you know, you have to go into the cache and I could do another page full of test cases. And this was just, like I said, a simple login screen. So as it becomes more and more complex, you can see how you can come to it from all ways. And the way I look at it is always like following a route. You know, when you have the point of the plant where the roots start, it's like that. You just keep growing and going. You start following a path and then you go, oh, I could do this and then maybe go here and then maybe I go there. And so that's how you build your test cases. You just keep going inside and inside and inside, and you want to get to the end of the route in every way, right? So you start at the beginning and you want to get to the end of the route, and how can you make that break, right? So, and now, I mean, till now, security was not a big issue, but in the last few years, security has become a big issue. People are being hacked. You know, you keep hearing about, you know, Chase being hacked or this bank being hacked, your credit cards being hacked and all that stuff. And that's because security is not getting tested that way. And even you as a user needs to be very careful that whenever you go to any website and log in, the lock appears on the top. You are always in HTTPS mode. If you, and I think that is something I should tell everybody, that please do not go visit any site if you don't see the lock, because that means that site is not secure and they could be capturing your data and doing anything with what you're entering. So that is something that you have to think. As a tester, you are looking out for your customer. And it's also a lot of fun. You know, just doing this thing for me yesterday, I had so much fun just writing this, because I went on and I said, oh God, I've reached 6 pages. No, let me cut them off. Let me stop, because that's how much fun I have. And really, you know, whatever job you do, you should have fun doing that, because without that, you'll get bored. And so, and I want to say, I started off as a developer, and I used to do gray box. One of my first jobs in the US was to do gray box testing and also to do code review. And I found that I enjoyed finding problems more than writing the code. So I moved over to that, because it's about enjoying what you do. And that's something and that's why I try to cover stuff which is also not just software, but also others, because I am sure, like my own son is a chemical engineer. So I wanted to make sure that to show, and he is now doing testing as a part of being a chemical engineer. So I just wanted to make sure that all of y'all understand that testing is not limited to software. I know in this, I am a software test engineer, but I see the value of testing everything that we do.
Yeah, so Under the non-functional security test cases, it says verify the implementation of an SSL certificate. And I was kind of just wondering what exactly is an SSL certificate and like why would you need it in the login?
So you know where you have the HTTPS, have you ever gone somewhere and they show that little lock on the top of the screen and there's an HTTPS over there?
Yeah.
So what happens is there is an encryption that happens in the data that you are sending from your browser to the server at the back. And that encryption requires a certificate. And so that SSL is Secure Socket Communication Certificate that would be installed on the server. And so what happens is when your browser looks at that, it knows, oh, okay, this is certified, and so it'll go into a lock. If that is not certified, it does not have a valid certificate. If it has a fake certificate, you will not see HTTPS, or you will see this bad error message saying that we don't recognize this token, because sometimes people put fake certificates there and they will say we don't recognize this entity who gave this certificate. So the certificate ensures that it is secure, and there's only very few companies that give certificates. So is one of them, and then you'll have one or two others that actually do certificates. So it is something that ensures that your data is being encrypted between you and the backend. That's a very good question.
Yeah, so in the beginning you mentioned black box, white box, and gray box testing.
Mm-hmm.
In what instances are each of them implemented? Like when do you, or companies, or basically when do you implement it?
So usually black box testing is done when they want a person to test a system without the knowledge inside. So more of the end user testing. So it's called acceptance testing or end user testing. So that's when you do black box testing. And when you're early in software development, like, it's 3 months and 2 months, and you still have a year to go, then the testers will work alongside developers and they know what's happening. So sometimes they will go into the code to see how the developer has written code, and then they will come up with their own code on how to test that, because they'll say, maybe he missed, this should have not been an integer, this should have been a date field. Oh, let me try testing it as this and see what happens if I do this. So that is where you want to go deep in small components. So they're used mostly when you're testing component by component. And gray box is sometimes just used by people who do not know enough coding. So they are not very good developers, but they would like to go there, or they would think, so they start off by gray box and eventually get into white box. So they know the system as a black box and they're making their way into white box. So it's like in my organization, I have chemists who need to do the black box testing, because my product is going to be used by chemists in pharma companies. But then there are, as they, some of them have become interested in coding, they've taken classes in Dianza, they think, so now they're starting to make their way into gray box, right? And eventually they will into white box, but that's what happens.
Okay, thank you.
Okay, so what happens? Now you found a problem. So that is either called a defect or it's called a bug. And usually the earlier you find the bug, the less expensive it is to fix the defect. And I'm actually showing something. So if somebody was writing up how this is supposed to work, so there's still no coding has started. They're just writing up how they plan to it. And if you found like, hey, you forgot to make this HTTPS, that's the least costly, because all he has to do is change his requirement at that time. Then you find it during coding. The next thing is during integration or component testing, it becomes more expensive, because now you might have to go down here to change the bug. Sometimes the problem was in the requirement, so it's become more expensive. Then the system is already built, so it takes more time now to fix the defect. And if it was already released to the customers, then look at it, how expensive that can be. So the idea is always to find, usually the goal is to find it right here in requirements or in coding stage. And so what happens is usually you write a defect either, there are a lot of defect management systems, and you will write them, you explain to a developer exactly how you came across it. Sometimes it may be you did a lot, and then, what were you expecting? What did you see? And usually you attach a bunch of screenshots, logs of what actually happened, so that the person who's fixing the defect does not need to come back to you and say, hey, what happened? Can you show me this again? They should be able to fix the defect. And even you 10 days later, if they come and, if somebody comes and tells you, oh, I fixed it, or can you show what happened? And you also don't remember, because by then you have found 20 other defects. And then what happens once, so the developer says, I have fixed the defect, now what? So you first go back to what you had written, you follow those, verify that the defect is fixed, then you talk to the developer, you ask for impact and ask them, what else should I test? And then think creatively, again, use that curiosity to test around the boundaries, and you may need to rerun the test that was causing it. And all these set of activities is called regression testing.
I was just wondering, what do you exactly take into consideration when like writing out like the design criteria that you like use to test out products or software or something?
So you actually use the same design, whatever the, everybody writes a design document. I think you guys must have covered that in your product design thing. So they usually write a document like, we need this to happen. So you take that, and then you start thinking like, how could this have gone wrong? So at each step, first you validate that it is working as it was designed, that as the designer envisioned, and then you think about, what could have gone wrong here? Well, if I was going to make a mistake, and you have to go into that, your attitude has to be that I have to break this. I have to find a way to break it. So if they said 1 plus, especially when it's formulas, you'll find that there'll be something like a divide by 0 or something that someone has forgotten to do, and you have to start using that. So you use your engineering mindset. If you know enough about development, did they use long or did they use short? Did they, so you start thinking like that, and then you start thinking. So just be inquisitive, and like I said, follow this tree, what I call the root method. Just keep going, digging. You'll find that it's amazing how much you can find with that.
Okay, thank you.
So when you're making some sort of a software product, having more layers of testing would be better, right? Mm-hmm. But is there a point where, like for you or for your company, is there a point where it gets to the benefit gained from having more tests, like more layers of testing, mm-hmm. is not enough to justify the cost of having that test?
So usually you figure that out by looking at the graphs of your testing. If you have come down and it's become stable like this, so usually what you'll see is with defects, you'll be like this, and then slowly over, like after defects are getting fixed, and then they come down like this. So you have to have that plateau, and you're not finding important defects. The problem is one important defect. If you have a high severity defect that goes out, you might sometimes even need to do a product recall. So imagine for me, I make a software that tests all our drugs. If I find a defect in that, and it has already gone to the drug manufacturer, and if one of our drugs does not show the right amount of ingredient, all of us wouldn't want to take that drug. So like today, this call I have in the afternoon is for somebody who's manufacturing a COVID vaccine, right? They want to use it in a different way. So we're going to have this call with them. But you want to make sure that the product is used in the right way. So that's why you wait. And yes, at that point, you can't say, oh, you know what, I was planning to test for 4 more weeks. But if you can see usually everybody follows something called metrics. They make graphs of the incoming defect trend. And once it plateaus down to where you're finding insignificant defects, yes, you release the product at that time. But of course, if the product is something like Facebook or Netflix or something, it's not going to be a life and death matter to anybody. So you would, sometimes make the case like, we'll fix it next week. We'll push an update later. But if it's your car with Tesla, with everybody driving autonomous, you wouldn't want that bug to be left there, right? You want safety. So wherever it's safety and where the product is actually shipped to the customer, it's not a website that does it. You really want to make sure you're very confident that the customer is not going to find a significant defect.
Okay, so at what point during the development process of the product do you start testing? And like, do you ever stop testing and debugging after you've developed it fully?
So usually we start testing on as soon as the developers start. So that's why I said you can start testing by reading the requirements and start thinking of test cases in the requirements so that you can actually sometimes find bugs in the requirements itself. So you start testing from day one, and usually you have to stop testing that version because you start working on the next version of the product. So you do stop testing on the day you release the product, and then the next day people start working on the next version of the product.
So I guess I just had a quick question. So, from your experience or any of your fellow professionals in the industry, has there ever been an instance where a product maybe has, undergone all the testing and, not even one bug was found? Is that something that's happened before?
No. What is said is you can never stop finding defects, but you can, you just have to make sure that the high, what's high and severe, because again, you can never predict the way the customer is going to use the product. So sometimes, you think the customer is going to go in a straight line and they decided to go do this and do that, or they're not in a supported environment. They're working thing. And an example is we recently had a issue where, when you install something, you say, we need 100 megabytes of hard disk space and we need this much RAM and we need this much thing. So this customer had all that set up, and after installing, they went and removed the hard disk and they removed a bit of RAM, and now the software does not work. Now, what would you say? Is that a defect? And the customer says, hey, you should have popped up a message and said, we can't work, but we said we did it. And initially, we don't think somebody's going to pull things out, right? So it's always also sometimes the customer, this thing, but you can't blame it. Over there, we decided, yes, we will have to, maybe we have to put a check in later to, do that. So the thing is that there is no software that is defect free. There's nothing like that. You can always find something, but it's, it's how easy is it to find that defect?
I have a quick question. By the way, this was really good, Babita. That brought me back to some nightmares back in the good old tech days. Given that this is a nonprofit, we're looking at obviously doing things on very, very limited scale, but robust enough to have a strong splash as all the services are blossoming. So there's two areas of questions that if you could touch upon. One is documentation for a nonprofit, documentation of not only test cases, but versionitis, or what kinds of systems would you recommend, as well as we're creating content, can you talk a little bit about the variety of platforms that people actually access stuff from, whether it's an iPad, it could be iOS based, Windows based, or whatever, and how do we actually test for that in-house in a simplistic way, a cost-effective way, I would say.
So let's address the first one. There are a lot of free tools now. I mean, I want to say I'm amazed by the amount of open source there is. From the time when I first started, everything used to cost a whole bunch. So if you want automation tool, there is, I mentioned Selenium and Robo Framework. Both of these are open source, they're free. There's Bugzilla that is free. That is a defect tracking tool. But in my previous company, I used to work for a tiny company. We did requirements management in that same tool. So we created two components. One was requirements, one was defect. And that way we could link things up. And I think there are a lot of wikis that are freely available, that are open source. So I would suggest using a wiki for collaboration and for capturing your requirements. Bugzilla maybe for, doing defects. Maybe there are more. This is like from way back when I was in a startup that we were doing all this stuff. But I know Selenium and Robo Framework, my people still use those products. So I know that those are still available. And then I think, yeah, so I think that is what I would say is the best way to capture stuff. I am sure Google in all its thing, there must be something else also over there, but I haven't really gone deep into it. But for my own classes, I used to teach a class and everything was on Google Docs. So I would say that that's the other thing that you can do. And then platforms, first thing you can do is, do you want access from all platforms, right? You might want to say, I will only do Apple and, Macs and laptops, right? Microsoft and thing, or you want everything. So it's up to you. It may be good to actually take off something or just make it browser based. If it's browser based, Chrome works on all platforms. So do you want to say, we'll work with Chrome? This way you eliminate a lot of things. And you can do that. You can write code to say this will work only on Chrome or Chrome and Safari, or, you can pick that. But there are simulators available, so you really don't need to go out and buy every possible thing that you need. But of course, all of us nowadays, iPads, iPhones, I'm sure Android stuff, there are some everybody has. You could use that. But typically, I have not seen any Windows phones or Windows, like you don't hear of people saying, I want to access this using a Windows phone. So typically companies do iPad, definitely Macs, Safari, Chrome, and nowadays Internet Explorer. Most things don't support Internet Explorer. Edge is the new one. You can choose to support it. But if you support Chrome, I feel that if you support Chrome, especially for a nonprofit, it's not in a company. In companies, there are still some companies that don't like Chrome. But I would say just keep it Chrome friendly for now to start off with. And you can put up this thing called for best experience. I don't know if you've seen that on some website, they say for best experience, please use Chrome or something like that. And you could do that. I think YouTube does that. Just go to YouTube from Explorer. They have a very nice message. You guys should pick that message and put it into your code.
I have a question. But first, thank you for showing that this kind of field is something that you can approach from many different industries. That's not something I was aware of, and someone who studies primarily non-CS related stuff, I think that's really interesting. And so my question also kind of stems from that same place, where I'm wondering, is there a certain kind of framework or some kind of framework analysis that someone who's interested in getting into testing can start looking at in order to develop their testing mindset and kind of sharpen up the tools needed to find test cases and all that kind of stuff? And I'm wondering that because I know framework analysis has been really helpful for me in developing other skill sets. So I'm wondering if there's some equivalent on the testing side.
So there are a lot of like certifications and stuff. You'll find a lot of stuff online, but mainly testing is like, you can take a few classes. I think even Dianza and the UC extension and all offer some basic classes. So just get a little bit understanding of what it is, and after that, it's like I said, it's like and I'll give you examples. Like I used to go to a gym when things were still open and we could go out. And it was a small gym run by this lady, and she was going to put out flyers, and she said, I just printed these flyers, and she gave me. And I look at the flyer and I go like, here's a spelling mistake, here you don't have a punctuation, here. So, it just becomes your brain, right? Eventually that's what you become. You start looking at everything. So if you are a picky kind of a person, then you will really like this kind of thing. And for me, I find like such a joy. Like I'll find an issue and I'll say, and even now, even though I'm a director and I'm not supposed to be touching code, I'll sometimes just download the thing, I'll do something and I'll send it to a developer, and he goes like, who let her inside the code? Who told her where things can be found? So you get a joy And that's what it is. It's about having that getting that joy. And I tell you, like, even my chemists today, they have so much fun. And the first chemist we got, she came, when she came, and she was like, oh yeah, is this going to be boring? And now she's the one who's going in and writing code, and she's doing all this on the side. And she just had a baby, so she says, oh, while I was nursing the baby, I decided to start learning to code, because it's just the joy that she got now about with doing that. So it's all about just being inquisitive, just that curious George kind of mentality. Just keep digging.
Quick, thank you, Bobita. It was really nice, hearing your experience and, some of the information. A lot of it was new to me, and I know I can use it not just in today's project, but in the future for really anything I work on. And I'm sure everybody in attendance now is leaving with a bit more knowledge about testing and just the mindset and how it works. So thank you so much. And with that, I hope everybody enjoyed. And yeah, thank you guys for coming, and have a great rest of your night.